Right, guys, so we're going to look at, so I picked one from practice 4. Let's look at solving this inequality. I don't know whether my video is going to allow me to write clearly or not. Right, so we have a non-linear inequality. How do I know it's non-linear? It's got an x squared. Good. All right. So when we solve an inequality, first step is to solve the equation. Right? So we need to know, where does x squared plus 6x equal 40, and then we can decide where it's less than 40 and where it's greater than 40, and then pick the right side. Right? So in this case, we're not actually trying to figure out a region. Why not? Yeah?
If we figure out a line, then the region will be on one side of it.
But I'm saying we don't want the region. Why am I not asked for a region this time? Why is it more specific? Yeah?
Is it because we're only finding values in x-axis and so we're not working with the y?
Well, we kind of are still using the y. The y is a number, yeah? The y is what number in this case? 40. When we were dealing with regions, remember we were solving things like, where is x squared plus 6x less than or equal to y? So we weren't being specific, right? But when we've got where it's less than or equal to 40, so let's imagine we have a line like, it could be a quadratic like this. This line is where y equals x squared plus 6x, let's say. Right? So if I change that y to a 40, right, I'm looking for any points on the line specifically that would have if this is the axis, the y value would be at 40, yeah? So I'm only actually looking for specific points, let's say. I'm a little sketch. So what does that mean? Well, that means if I consider the axis, then this x value here would give me 40. This other x value would give me 40. The times when x squared plus 6 is less than 40 would be all these x values in between, because the line represents what x squared plus 6x is. Right? If I'm only solving for where is y greater, then I've got a whole region, because this whole area, okay, would represent that, right? Not just the line. So remember I was saying before, when we talked in when we were talking regions, the title of the exercise was solving inequalities in 2 variables. When you've got x's and y's, you're dealing with regions, right? When you're dealing with only x's, 1 variable, then you're looking at just the line itself. Where is the line above or below a certain value? All right? Because the line is not a line, what is it? An infinite number of points, and an infinite number of points has an infinite number of values. And the lowest value that this line will take will be whatever that turns out to be, yeah? All right. So we are only looking for x values that would give me, if I chuck them in, a value less than or equal to 40. Okay, so that's what we're looking for. So any ideas what the first step would be to try and figure out what those x values, where they equal 40 are? Yeah?
If you rewrite it saying x squared plus 6x equals 40, then you can minus 40 on both sides and get a quadratic equation in standard or the standard form.
Yeah. But Jack, haven't I now changed everything? It's a different thing now, isn't it?
Right. Equivalent. Or equivalent distribution.
Okay, and what does that do? If I give an
It's a different line, but it has the same solution.
good. That's an important aspect to remember, yeah? What I've done there does not give me the same diagram or the same graph, okay? But it doesn't change the solutions. Right? So it's an equivalent form. It's a, like I say, equivalent transformation, right? So I can solve this to get solutions. Those solutions are the same solutions as this. These two things, if I plot this and figure out where it's less than 40, it's not going to look the same as this being less than 0, for instance. But the x values will be the same. Right? So what do I do with 6x squared plus 6x minus 40? Anyone?
It's easy to factorize.
Is it? Okay. Cameron at the back then. Jack's given you a clue. It's easy to factorise that one. What are you trying to do when you factorise? What's going through your head? What are you trying to find? Yeah, exactly. So, and because it's negative, Cameron, what must I know? Yeah. And if one of them's negative, one's positive, and then when I add them together, I get a positive answer. What does that tell me? The larger number must be the positive one. If you add two numbers together, one's negative, one's positive, then if my result is positive, the bigger one must be positive, right? Also, what that tells me is if I'm adding a negative and a positive, it's the same thing as just subtracting, right? So what that also tells me is that the difference between my two numbers is 6. Gives me a clue, right? So, Cameron, what numbers multiply to make 40? 10 multiplied by 4. There you go, because you've got the difference of 6 there. This must be a positive, and this one must be a negative. Okay? So my brackets, I've only got 1x squared, so I can do x, and in this bracket can be alright, I've written plus 10, I was expecting that, or minus 4. Alright? That's just this bit, so I still need my equals 0. So what are my two solutions? Using this a lot. That's here. So x is negative 10, x is positive 4. Okay? So that's why before when I was saying, right, use this information, if you've got the graph, find out where they cross. So what I now know is those are my two solutions to that. But what I need to solve is not where it's equal to 0, but where it's... I need to know where x squared plus 6x minus 40 is less than or equal to 0. Because that will be the same thing as x squared plus 6x is less than 40. So I've got my two values, x equals negative 10 and x equals positive 4. But how does that translate into a solution like in an inequality? Because obviously when we can't have equal signs when I've got an inequality to give an answer to. Because how many solutions are there to an inequality? Infinite. Yeah? I'm setting the boundaries, that's all. Those x values that I've got, they're the boundaries. So if I say equals, I'm saying there's only two solutions, but for an inequality, there's an infinite number of solutions. So I need to just use those as my limits, they're my boundaries. So which side of them do I go? Because obviously, I've only got one sign. Do I just chuck that sign back in, less than or equal to negative 10, x is less than or equal to positive 4? What do you reckon?
No, be inside those two.
Because what's wrong with this statement that I've just made? It's really only one statement. Which one? Yeah, because if I say x can be anything less than or equal to 4, this less than or equal to negative 10 is a bit redundant, isn't it? Right? Of course, if it's less than, well, if it's less than 4, it's not necessarily less than 10. So actually, this is the overriding one, actually. Because if I say both of those, it has to be the other one, yeah? Has to be this one. But I have to pick a number that abides by both limits. Yeah? So if I pick 2, that is less than 4, but it's not less than negative 10. So it doesn't abide by that one. So that 2 would be wrong. So actually, I have to ignore the pos 4 bit. That's beyond because of this one. But that just means that my statement must be wrong. Yeah? These are... Oops. These are just not going to work. All right, so I need to rethink. So there's a couple of methods that we can do. All right, there's the method in the book, and there's the graphing method because we're very used to graph. Now my clue is up here. Look. All right. Now this graph is not quite right, so I'm going to get rid of it. That graph is not quite right. Computer's a bit slow. It hates it. All right. So, what we need to do, this is where we're now using your knowledge. It doesn't need to be hugely accurate, this, but we're going to draw a little sketch of what we think x squared plus 6x minus 40 will look like. And we actually only need a couple of things. Right? What are those things that we know now?
We know that the parable coming down to y.
So we know it's this shape, yeah?
Yeah.
Because it's positive. It's not the other way. If it was the other way, it'd be a negative x squared. So we know it's that. I've not drawn it on the curve yet. It's that, not that one. Okay, what else do I know?
It's gonna, the bottom of the curve will be at minus 40.
No, it won't. I get you, but it's not the bottom of the curve. Hey?
Look at 0.
It would be
Let's pick something else that we know, the most basic one. Jacques?
the two solutions.
Yeah,
So the
these
two-
are the things we've worked on. So we know it's minus 10 and positive 4. So I can just do a rough sketch of minus 10, positive 4. Now what you're saying is not the bottom of the curve that's not minus 40, but
Right.
the y-intercept. So I do know. Now it doesn't actually matter, right? I don't need to draw my sketch and go, I need to make it bigger and cross at minus 4. But it would go down, kind of come below minus 40, go up through minus 40 and back up. I don't actually need all of that information. All I really need is the shape, which direction it goes, and these two numbers, yeah? They're the only ones that are actually important. This whole section, how far down it goes, doesn't matter, because all I actually need to know is where is this graph less than or equal to 0. Yeah, that's what I'm looking at. I've not done that one. I've done this form. Remember, those two will look different. But this one's nice and easy to draw because I've got my solutions. So where is this, which is the curve, less than or equal to 0? Jack?
In between your two solutions.
In between my two solutions. So I know x equals negative 10 there, and x equals positive 4 there, and the line is less than 0 when it's under the axis. So I'm looking at that point. So I am only interested in this region here, yeah? So how do I describe that? I describe that by saying that x needs to be actually not less than negative 10, but greater than or equal to negative 10, and less than or equal to positive 4. Okay? So I've done that by looking at the sketch. What's the other way? Well, should I pause? Are you all right with that? Should I pause and let you write that down? Okay. So the other method to do a check is, let me just rewrite. So we've got x squared plus 6x minus 40 needs to be less than or equal to 0. And we've decided we've got x equals negative 10 and x equals positive 4 as my solution. So let's pretend I haven't drawn the graph. I don't know what the graph looks like. But I've got to decide what the symbols are. So what we do is like we've done checks before, but we have to do more of them. So we basically pick different values. So I'm going to pick a value that is less than negative 10 and more than negative 10. So this is always risky, but Raya, pick me a value that is less than negative 10. Good. Negative 11 will do me. Owen, pick a number that is more than negative 10, but less than negative 4. Positive 1 could do. I'm not going to go that far. I'm going to stick closer to negative 10, but positive 1 would have worked. A bit closer, let's just do negative 6, okay? I was going to do even closer. I'm just sticking like 1 either side. 1 would have been absolutely fine. The only reason is I'm going to say that x, for this one, I'm going to pick x is, let's say 1 for that one, because it's less than 4, and x is 6 for that one, because it's correct. So I'm going to check either side of what these limits are. Yeah? And I'm going to figure out what this equals for each one of those 4. So what does x squared plus 6x minus 40 equal when it's x negative 11? So we've got negative 11 squared plus 6 lots of negative 11 minus 4. What do you get? Over to you. Work out all those 4 values for me using your calculators. I'll put it on pause. We've got those 4 values. So what does that tell us? Well, that tells me that this side of x is minus 10 doesn't work. So that's wrong.
Mr. Fox,
Yeah?
isn't x equals 1 minus 33?
Minus 33.
You're just saying it's simple if you know your subtraction.
Yeah, exactly, yeah. Check your answers. This side doesn't work. This side of x doesn't work because that's a positive. So it looks like in between these two numbers is what I want. All right? Because that's when we're less than 0. We've got negative numbers. All right? So again, that leads me to the conclusion that x must be greater than negative 10, but less than or equal to positive 4. Okay? Which one do you prefer? Graph.
Even if you don't graph it, imagine everything.
Exactly, yeah. Like even if you just do it in your head, isn't it? You know? It's good to just do a quick sketch though to show an examiner or something what your thought processes are.
Especially if it's contingency.
Exactly, yeah. This, by the way, is, especially this method, is quite a useful thing to get to know to do your checks, even if you graph it. Because when you get, obviously, in DP 1 and 2, you start doing your differential calculus and stuff like that, you have to actually show that a point is a minimum or a maximum. And you can do that by sketching the graph, the whole function if you want, or you can work either side of a point, and if it goes negative 0, you know it's a maximum. So that kind of process is quite useful going forward. All right? So just to recap what we did, because it's been a lot, you'll notice these questions are starting to get extended level. There's a lot more to them, right? So we started just with wanting to solve that inequality. So first step was to get a quadratic that I know how to solve, factorize it, figure out what the two solutions are, but then the next point is to interpret those two solutions and decide which side I need to be. So I can either do that through graphing, or I can do that by picking numbers either side of each solution. All right. How do I know, by the way, that there isn't something in between these two that would actually go above 0? Do I need to check every number in between, just in case? Exactly, yeah. I can't check them all. What's the only thing that will answer that question for me? It's basically the graphing again. You just have to know how a quadratic behaves. That's as simple as it, yeah? If a quadratic was positive, goes into the negative region, still negative, and then goes back to positive, it does not go positive between the two negatives. It goes more negative, yeah? Or it stays negative. So I know between two negative values, because of the shape of the curve, the fact that it is a U shape, that's how it's going to be. That's not always the case, is it, with functions? I'm just going to mention it now, but what functions do you know where you can't just make that kind of assumption? Yeah. So if you were solving something that does this, yeah, and you found two solutions and one was here and the other one was here, all right, there are some above, some below, right? There are others as well, aren't there, that you should find familiar. For instance, what kind of function is that? We've seen it lots. That's a reciprocal function, yeah? So again, if I wanted to pick where it's below 0, you know, actually there's a line here that I need to take into consideration. Right? So there are times where you can't make that assumption, but with the quadratic, I know the shape of it. So this is when knowing how functions behave is important. Quadratics are fine. Okay, so enough time. This question, we've just done D. Okay. Just done that one there. So you've got these ones to do. If you're all good, this one especially can, same idea, but have a look at it. All right. And on to the problem solving. So have a go with the rest of those. 20 minutes. 20 minutes, or was that wrong? Yeah, 20 minutes. Stuff. So if we compare, this is the question you get where this one is less than this one. So I want to know actually where the red line is under the blue line, yeah? Okay. So I'm looking for these points where, so this is what we've done before. So that's what it would look like if I just graph the two. So if I've got a graphing software, I don't need to do all this changing to a quadratic, all right? But just to confirm, if I put that one in, solving this one less than 0, look, it's at the same points, all right? So why do we worry about changing that situation into this situation? Jack?
Because we can actually figure out the second one.
Exactly. All right. What rule, what law do we need to solve this one that we don't have in this case? The null factor law. We are taking advantage of the null factor law to find the solutions to this one. If I were trying to do this one here, right, where the red is under the blue, okay, I'm struggling, right? People will say, well, I'll subtract, and then they end up with this anyway, and they're trying to keep subtract, we have to have that null factor law. But if you've got a computer, you've got a calculator, you don't need to, you just use this. Do you see, however, though, if the sign was the other way round in the question, I'd actually be looking for that way and this way, yeah, not in between. So that's why it's important to do the check, and that's why I will do the check on the quadratic rather than the original ones, because again, I might find it a bit harder to know how to draw this quadratic. Why? So if I asked you to draw 6x squared plus 4x plus 1, what's the problem with it? Well, also, what does it never do? It never crosses the 0. So how am I going to know certain points to plot? And I won't, yeah? So it's hard because the red one won't factorize to give me two solutions to equal 0. So I can't use that process. Right, so it's hard to draw that. The straight line is super easy. You all know how to do that. But I don't necessarily know where it crosses, but it wouldn't be too hard. But it's much easier to simplify to that one quadratic, know where it crosses the axis. You've got your solutions, so that's kind of the process that we're going through. Good with the question? All good? Yeah? I'll let you carry on, guys. Is it almost time anyway?
Got like a minute.
Couple of minutes till 5 to. Yeah. Stop recording.